Let's take a look at operations and permissions. We've already seen the pwd command to look at the current file path where you're inside, and we will see what's the importance of the working directory, the current working directory that you're working inside or where you're starting your programs. So with cd, you can change this directory where you're inside, and you can work with relative and absolute paths. And a relative path is a path that is evaluated relative to the current working directory. And you can also use dot dot for the parent folder, or dot for the current folder as a shortcut. So if you're using an absolute path, it always starts with root, and then it has all of the segments starting from the top of the file system tree. For example, here it's a folder inside of a home folder, and the absolute path starts at the beginning at the slash, and then has all of the segments. And the relative path is evaluated relative to the current working directory. Therefore, if we are inside of a home folder and using just the file name, then it works because it's relative to the home folder. So we can demonstrate this. Let me clean this up. So I can do this because this file name doesn't start with a slash, so it's interpreted as a relative path, and then it's basically uses the path to the home folder plus the slash the file name. If I'm going to a different path, for example, slash tmp, this is a folder where often temporary files from programs are stored, and I'm trying to use this file name, then it's obviously not found, because now the actual file name that is used is slash tmp slash test file, and this file doesn't exist. So instead I can use the absolute path. Let's see how this works. I'm users u. So this is my home folder, and this is the complete absolute path to the file. So this now works because this absolute path is used as an argument, and then cat, which just prints the content of the file, finds this file because it uses the absolute path. Let's go back to the home folder with simply cd. If you use cd without an argument, you get back to your home folder, and you see that we again see this tilde sign here. This means the abbreviation for home folder. And we can change into this data file. There are some files here. Now, I've told you that you can use the dot dot as a shortcut for the parent folder. So we can take a look at the content of dot dot. This is my home folder. So I'm inside the data folder, and I'm looking at the content of my parent folder. And I can also do, for example, this. This way I'm saying in my parent folder, there is this test file. So cut the test file in my parent folder. And what we can also do is we can manually combine these to an absolute path. So if I'm using the absolute path to my current working directory, and then combine it with this name, we see that it also works. During evaluation of this path, the system basically sees, okay, this means the parent folder of this folder. So these are basically cancelled out. and this is the path of the file that is accessed. So I can take a look at the parent folder or also the parent folder of the home folder. So this is the difference between relative and absolute paths. So absolute path always starts with a slash and has the complete path from the root of the file system tree until the end of to the name of the file or folder you want to specify. And the relative path is always relative to the working directory that you're currently inside and run the commands in. We've already seen the ls command. So simply listing the files in the folder. So let's take a look. Just ls will give you this output, and you see that there are some there's a different colors used for different types of these files. We can also add arguments, and these are often arguments often started with a minus, and then, for example, show with an A also the hidden files. So -a means please also list the hidden files, and hidden files are by convention files that start with a dot. So we see suddenly there's also this dot. This is a hidden file listed that was not listed before. And also the dot and dot dot short hands for the current and working directory are also listed. We can also add an L, and with an L you will get a table with some more information. Now, how to figure out what are the arguments for a command? For this, there is an online help on Linux systems, and these are called the man pages. So let's try it. The command is called man, and we can give it just the name of another command, and then we are inside of this man command and can take a look at this manual page. And inside here, we can use our keys to scroll up and down, or for example with a small g we can scroll up, or a capital G we can scroll down to the bottom of this manual page. And you will find in this manual page the description of the command, what it's doing, list information about files, and also description of the arguments that you are allowed to use with the command and what they will do. So often you are using a command and then you're reading the man page and you find new arguments that you did not know about that are very handy. So it's good way to learn about the commands that you're using. What we can also do in this man page is we can search, and for this you have to enter a slash. Then you will see here on the bottom you will get a prompt where you can enter something. So if I'm entering the term file now and press enter, then file is highlighted here because it was found in the manual page. And with a small n, we can jump through the occurrences. And with the capital N, we can jump upwards to see the occurrences in the upward direction. And as you can see here, Now this application or program behaves differently than the commands that we've seen before. Before we've seen that the command is running, it executes, it produces some output that is printed on the terminal, and then we get back our prompt. In this manual page, this command takes over the complete screen and interprets our commands. And as you see here, it always updates the complete space of our terminal. And to get back to our prompt, to our normal shell, we can in men use the Q character, and then we are back at the terminal, and also the output that was produced is gone, and we will see our normal history. So this is a different kind of command that is depending on the program, it behaves differently and is not simply printing something to the terminal, but takes over the complete screen and then is interactive. Yes, please. The flag? Uh, ah, minus AL. So these are the arguments to ls that we can give to change how ls behaves. By minus we say now come some one or multiple arguments, and these are the shorthands, and we can use ls to look at what they do. So minus a means do not ignore entries starting with dot. So it also shows these hidden files. And L, we can go down where L is specified. Here it says use a long listing format. So minus L gives us this tabular output of ls. And so we had a little detour about man pages, so it's quite useful. You see, you had the question, what this argument is doing. You can take a look at the man page and see what the arguments are doing and what other arguments are available. So these man pages are available for many commands on the Linux command line, or even man itself, where it explains, okay, man is the system's manual pager and so on, and then explains a lot of stuff about this man command. Yes, but let's take a look at the ls output. So now I'm using L and A, therefore I'm listing all of the files, including the hidden files, and I'm using this tabular output. Let's start from right and go to the left. On the right side, we have the name of the file or folder. And then next comes the date of the last change of the file folder. And then we have a size for files. It is simply the size of the data inside of the file. For a folder, it's a system-specific size that is a little bit hard to interpret, so you can simply ignore it. So these are only basically interpretable for these normal files. Then we have the owner and the group of the file. So this means that these files belong to this user account, and they have this user group as an owning group. And then we have another internal number, and then we have these permissions, and we have 3 blocks of 3 permission bits that we will talk about in a second. And then we have this the first character in the list in this table we have either a D, which means a directory, or we have a minus, which simply means it's a file. So there are other types, but these are the most common one. Now, if you want to know the size of a directory, therefore the sum of all of the file sizes recursively in the directory, you can use this du command, du minus sh, and then the name of the folder, and then du will traverse recursively through all of the subfolders and look of all of the files and then give you the sum of the file sizes. Now let's take a look at these access permissions because they're important to understand what you are allowed to do with files and folders. As explained, we have these three groups of these three types of permissions. The three types are read, write, and execute for files or change into for directories. So read is easy. You're allowed to read a file. Write, you're allowed to change it. Or you are allowed to execute if it's a program, then you would be able to execute it. And we have these three groups, and these are then set for the owner, for the group of the file, and then for all other cases. Now we can think about how these settings are interpreted. For example, you want to edit your own file, you want to overwrite it. If it's your own file, so you are the owner of the file, the system will take a look at the first 3 bits. They match because you are the owner. And then you see, okay, you are allowed to edit the file because the writing bit is set. And that's it. Let's say in the project folder, there is a file from one of your colleagues and it belongs to him. So it's not, you are not the owner of the file, but the group is set to your project group. Therefore, if you want to simply open it, the system will see, okay, you're not the owner, but you are in the group of the file. And then it sees, okay, the read bit is set, you're allowed to read the file. But if you want to edit it, you won't be allowed to edit it because the write bit is not set. Let's say you're not the owner of the file and you also do not belong to the group that the file is set to. Then the last bits apply to you. And then in this case, you would be allowed to read them, read the file. The owner can also only be changed by the administrator. So this is the root account on the system because this is security sensitive. But every new file that you're creating by default belongs to you. So you are the owner of the file. So, or specifically your user account is the owner of the file. And you are allowed to change the group that the file belongs to with the change group command, and then you can simply specify the name of the group and then for what file or folder you want to change it. And you can change the permission bits. And for this, there is the chmod command, change these permission bits. And here, for example, you can, for the group bits, you can add the write bit to a specified file, and then this write bit will be set. Or you can, in this case, for the other groups, others group, you can remove the write bit with -w to remove the bit. And you can also apply these changes recursively to files in a certain directory when you're using the -R argument to chmod. This way you can control the permissions of your files inside of your home folder. Maybe this is not so critically because only you are allowed to access your home folder. But let's say you have a project on the cluster and you have your colleagues and you have the project folder where all of your um, uh, configuration files for your applications and the input files are stored. Maybe you have some configuration files that you don't want your colleagues to change because you're currently running a program that uses this file. Then maybe you can disallow your colleagues to write them, or you have a folder where you have um, some other important work. Then you can disallow them to even look at the content of the folder, even if it is inside of your common project folder. And it's also a common practice inside of your project folder to simply create a folder that belongs to you. It then has your name or the name of your user account. So other people know, okay, these are the files that my colleague is working with. And then you can accordingly control the permissions. So this way you can also, for example, let other colleagues or share some files with some other colleagues. Now we've seen the mkdir command to create a new folder, a new empty folder. There is also a command to create a new empty file. It's called touch. And if you touch an existing file, then it will simply update the timestamp of the file. Next, there is the rm command to remove a file. And you can also use rm-r to remove a directory recursively, so the complete content with all the subfolders and files and so on is removed. But you have to be very careful with the rm command because there's no undo. Once you execute the command, it can't be undone. So there is no trash bin or something where you can rescue the files, they are gone. And then there is the copy command to copy a file. So it's basically cp, then the file that you want to copy, and then the new path or file name that the copy should have. And you can also copy directories. But again, you have to be careful. If you use a name that already exists, then it will be overwritten. So you could also, in this case, lose some data if you're not careful. And also the move mv command, with this one you can move a file directory to a different place or rename it. And again, if it's already existing, it will be overwritten. So also in this case, be careful about what you're doing. Another common thing that you may want to do is to search for some files. For this, there is the find utility. Let's take a look. If we just use find, let's say I'm inside of my home folder and I'm just say find on the data folder, then you will see it will just print all of the paths of all of the content of the data folder. So it recursively traverses through the folder that I give find, and then it shows these things. I can also give it some more arguments to filter the output. For example, I can use -type and d, and then it will only show directories, or I can use F to only show files, and then directories are not shown. Additionally, I can use, for example, the name. So if I say I'm searching for a file called hello.sh, then it will only show the found file with this name. So it's a file and it's called hello.sh, so it will be printed. But beware, if you have like a difference here, um, then it won't be printed. But in this case, you can also use iname, and then it's a case insensitive search or comparison. And you can also use patterns. And let's use a pattern here. With this command, I'm searching for a file that starts with hello, and I'm using the case insensitive search. So as we see here, it prints files that start with hello, for example, hello.sh, hello2.txt, or hello42.sh. Because this asterisk is interpreted as anything, any sequence of characters could go here, even the empty one. For example, I can do this, and it will still be printed because this can also be nothing is follows. And we can also, for example, use it like this. So this prints all the files that have a true inside of their file name. Yes, please.
Does that work for the first filtering? I mean, find, if you print data, then BAT, then start, this work?
Pardon?
I mean, if you use find
Mhm.
and then you use the asterisk, then would the filtering again works? Or you can do only.
So the arguments defined are always the first thing is the directory that you're searching inside. You can say data, or you can also use dot for the current working directory. So then it would use look in all of the files and subfolders of your current working directory. And then you need some kind of way to limit the output of find. So you would need to use iname, for example, and then this as a parameter. And there are some other expressions that you can use, for example, with a set of characters. And there is a way to use these kind of wildcards characters also with your normal shell, not as an argument to find, but as an argument simply as a part of file names. And they work kind of similar, but you have to be careful. Let's see. What happens? I'm doing ls, and it then prints hello 2, hello 42, and but it also prints this folder because it also contains a 2. And what is happening is that this is not what ls is doing, this is what the shell is doing, and this is called globbing. And this means that the shell will interpret this again, not as in a straight way um, as a name, but it will use these as for pattern matching, and then look if these files and folders exist, and then generate this list of these file and folder names of existing files and folders. And you have to be careful about this. For example, if you want to remove all of the files that are ending with a .sh, for example, like this, then you maybe delete something that you do not want to delete. So it's you have to be careful about these patterns, and it's often a good idea to first see what is matched um, by these patterns, for example, like this. And when you're completely sure that you only match the files that you intend to work with, that you intend to delete, then only do the real command. And then it can also be a powerful thing to use these patterns, these expressions. Another thing is packaging of files and directories. So sometimes you want to download a whole directory with a lot of small files, and you could copy them one by one, but sometimes it's also more convenient. Maybe you want to send them to a different colleague anyway. Then you can create an archive, and you can, for example, use tar. This is a um, command used in Linux and macOS Unix systems to create these tar archives. They are similar to zip archives in that they are combining multiple files and then compress them. And with this arguments create a compressed archive, and the archive name is this, and put this directory inside of it. Then you will create this file with all of the files inside. And then you can use tar-xf to decompress this file again. And for example, you could then download this file and send this to another person. Or you can also use zip if it's more convenient for you. So zip -r and then the file name and then the directory would then recursively go through directory and put the content into the zip file. And to decompress it, you can use this unzip command and the archive name. Here is a cheat sheet, a table with the commands that we've looked at, and another slide with more commands.